Welcome back, friends. Now we are moving into the next part of inheritance mechanism, that is the sex linked diseases or sex linked traits. So, here we will see those genes associated with a disease, and these genes are located on sex chromosomes. Right, as already we mentioned, there are two sex chromosomes, X and Y. Right, if the individual is female, there will be two X chromosome, and if the individual is a male, there will be at least one Y chromosome. That means usually a male will have XY as the sex chromosome set. Okay, so with that basic data, we are moving into this X-linked dominant trait. Okay, which means that this trait is in the X chromosome and that disease is dominant. That means when the genotype is dominant, then the disease will appear. Okay, so what are the features? The first feature is that all the daughters of an affected father will be affected. That means usually the transmission is from father to daughter. Right, there is a high probability for transmission from a father to a daughter. Then it will be X-linked dominant trait. Okay, and the second feature is that they appear in male and females, just as in the dominant or recessive traits of autosomal disease. But often they will be affecting females. Right, there is a high probability for females compared to male offsprings. And one important feature is that they never pass from father to son. It is impossible, it's nearly impossible to pass from a father to a son if it is an X-linked dominant trait. All right, so an affected males must have affected mothers. So if a son is affected, which means that the mother is also affected, and there is no possibility for the transmission from a father to a son, but it is highly possible to pass from a father to his daughter. Okay, so when the disease condition, in case of disease condition, this will be the situation. That means XY, this is the male with XY, and A represents the dominant character. Okay, the superscript A represents the dominant character, XAY, and this individual is affected. Right, this individual is affected. Otherwise, the situation may be capital A, capital A. That means in case of a female, capital A is possible because there are two X chromosome. Or in the female, there is another possibility that she is having a heterozygous nature, capital A and small a. In all these three situations, these individuals will be affected. In case of no disease condition, if in case of a male, the male should be X small a and the female should be X small a, homozygous for the recessive trait. Okay, so this will be the condition. And we can see examples. Rett syndrome or hypophosphatemia, these are examples for X-linked dominant trait. And this is the pattern or a model disease pattern, transmission pattern for X-linked dominant trait. You can see the transmission from this father to the daughters. You can see all the daughters are affected. All the daughters of this father was affected, and here you can see two sons are affected. But see, the father is not affected. The father is not affected, but the son is affected. So definitely, based on the feature we explained, the mother should be affected. Right, the mother is affected, and hence the transmission is from mother to son. Okay, but if a father is affected, all the daughters definitely will be affected. All right, so if the individual 10 marries to a woman, and even if she is healthy, all the daughters of that family will be affected. Okay, so this is about the pattern. You can also check the genetic status. Okay, so here it will be, this father will be X capital A, right? X capital A Y. And we can clearly answer why all the daughters are affected if the father is affected. It is because, for an individual to develop, there should be the X chromosomes. Suppose this is the female or the mother, this is the mother, and this is the father, right? This is the father, and they got daughter. If these parents, these family have daughter, and how a daughter is being developed. For a daughter to be developed, there should be two X chromosomes, right? There should be two X chromosome, and one X chromosome will be contributed by mother, and the second X chromosome must be contributed by the father. All right, and here in this situation, you can see here the father is unaffected with the X chromosome, or the father has an affected X chromosome. In that situation, all the daughters will be carrying this affected X chromosome, and that's why all the daughters are affected. There is no possibility to obtain a disease free X chromosome from a father if he is affected, right? In this situation, in the situation where the mother is affected and father is unaffected, in that situation also you can check the father is unaffected. Okay, the father is unaffected and the mother is affected, right? The father is X small a, but the mother is either X capital, at least one capital A should be there, right? The mother is at least having at least one capital A. In that situation, you can see if the mother, if for that family, if there is a son, okay, and the son will definitely has to obtain Y from the father, and X has to be obtained from the mother, and the mother, if the mother is affected, which means that there is at least one X capital A. So it is possible to carry this X capital A to transmit the X capital A to the son. Okay, so this is the situation of transmission in case of X linked dominant trait. Now the next one is X linked recessive trait. Okay, X chromosome associated gene which will cause a disease when it is in the recessive status. Here you can see males are more affected. All right, males will be affected in more probability. Then there is a tendency to transfer from mother to son and father to daughter, right? The transmission probability is from mother to son and father to daughter, right? The X-linked dominant was actually it was not like this. It was from father to daughter. That was the more probable chance. Okay, then here you can see never passed from father to son, never passed from father to son, and do not skip generations. All right, they do not skip generations. So when the disease condition occurs, when there is disease in an individual, this will be the genotype. There should be a small a. Okay, in the recessive condition, the disease will be experiencing X small a, or if it is female, X small a should be the genotype. Okay, and the no disease condition is like at least one capital A will be there in that individuals, right? And we have examples like hemophilia. The classic hemophilia A belongs to this X-linked recessive trait. Okay, then the muscular dystrophy, Lesch-Nyhan syndrome, all those are examples for X-linked recessive trait. And you might have heard of the story of hemophilia A, right? Then this is the pattern of inheritance. Here the red dotted ones are the carriers. Okay, Here you can see this individual 2 in the generation 1 is the carrier, but she is unaffected, right? And it is possible to have a son with who is affected, right? And if he marries to a healthy individual, even if he marries to a healthy individual, it is possible to have carrier individuals in their offsprings, right? So in that way, the transmission occurs. Okay, usually they do not skip generation. All generations are affected. At least one individual in every generation will be affected. That is the situation. Okay, so this is about X-linked recessive trait. You can check the status by writing the genotypes. Okay. Now finally, the last pattern of inheritance is Y-linked. Okay, it also could be a Y-linked chromosome, and definitely it's easy to understand. Only males will be affected, right? Only males will be affected if the disease is Y-linked. Okay, and the trait is definitely it will be passed from father to son only, because it is a Y chromosome, and Y chromosome is limited to the male organisms. Okay, so if a man is affected, all his male offsprings will be affected. Okay, since it is limited to male, and also the Y chromosome is not bearing a high number of genes, there is only limited disorders associated with Y chromosome, and most of the disease associated with Y chromosomes will be causing or will be leading to infertility in male, right? And examples like Y chromosome infertility and some cases of Swyer syndrome. These are some examples for Y-linked trait. You can see the chart also. All the family, all the males in a family are affected. All right, all the male individuals in a family are affected. Okay, so this is the situation for Y-linked trait. All right, now we'll consolidate the features we explained for the different patterns of inheritance. Here, these are the most significant or highlighting features of all the 4 types of inheritance except the Y. Okay, then the autosomal dominant, usually they do not skip generation, but recessive will tend to skip generation, right? And the autosomal dominant will be that means affected parents can have unaffected children, but in autosomal recessive, unaffected parents can have affected children. They have opposite characters. And in case of X-linked dominant and X-linked recessive traits, the dominant trait will transmission is like all the daughters of an affected father will be affected, right? All the daughters will be affected, whereas X-recessive traits are the males have more probability for getting infected. Okay, usually dominant traits never pass from father to son in case of a X-linked chromosome, never pass from father to a son in case of X-linked dominant trait, right? But an X-linked recessive trait, there is a transmission from mother to son and also from father to daughter transmission. Okay, and usually there is less frequency for transmission from father to son in case of X-linked recessive trait. Okay, these are the consolidated features. You have to remember these features when you are going to analyze a pedigree chart. Okay, here again I am giving you some more key features. If it is an autosomal disease, you have to check whether it is father to son or not. If it is father to son, you can say that this is an autosomal disease, right? And if they are present in all generation, if the disease is present in all generation, that means at least one individual in every generation is affected, then you can say that this is autosomal dominant, right? And if they tend to skip generation, it is autosomal recessive, right? So remember, if it is father to son and then skip generation, then it could be autosomal recessive. Or if they are present in all generations of a family, then it could be autosomal dominant, right? And if you want to check whether it's X linked, then you check for whether the transmission is father to daughter, right? If it is from father to daughter, then it probably could be sex linked, right? And if it is father to daughter, it could be not only sex linked, it could be sex linked dominant, right? And if most of the males are affected, then it could be sex linked recessive. These are some probabilities. Okay, definitely there will be some variations when you check the real examples. And this is again a consolidation of the features we already explained. I'm not supposed to discuss it again. And here this image gives you an idea about various genetic disorders associated with the specific chromosomes, right? You can see various examples. Already we have seen some examples under to explain different inheritance pattern, right? You can see the for example, you can see the sickle cell anemia. And sickle cell anemia is the chromosome affected will be chromosome number 11, right? And there is a small explanation also: chronic inherited anemia in which red blood cells sickle, then clogging arterioles and capillaries. That is the disease. A small explanation is also given there. And similarly for all the other diseases are given, and their basic explanation also being provided. Okay, this is a useful data for your reference. And by that I wind up this part of presentation, and I hope you can understand the explanations. Thank you for listening.